Hi, this is Rachel. I hope you had fun at today's class, and by the end of Sunday, we should be able to finish all the materials about K-means. So today I'm making this tutorial to help you get through homework 1 by using one of the machine learning platform called Big ML. Of course, you can conduct the analysis by hand using R, Python, MATLAB, anything you want. But in this tutorial, because Big ML is super easy to use, you don't need to code. We're gonna use that for this assignment. All right, let's get started. So hopefully you already had a glance of what's going on in assignment 1. So basically it describes a really common business situation that you have so many products in the market. It's sort of impossible for you to target at each one of them because there's so many of them. So it's feasible for you as a company to conduct some classification towards all of them, so you can make some target or have a sense of what's going on the market. All right, so for this question, we're gonna do some clustering or classification targeting at whiskeys. Yay! So the first link is sort of like an introduction about the flavor of whiskeys. You're welcome to have a glance at it. And the data set is here. So let's say what's going on. So there are 86 types of whiskeys and have 12 different taste categories, including blah blah blah, and there are different data sets. So if we care about taste, let's find the data set which has it. I mean, this is like purple, so of course. But I mean, yeah, this test file contains whiskey taste classification data, so it sounds like something we're interested in. So click in. It's a little bit messy, but you should be able to find like it has ID, distillery, body sweetness. Looks like something we are interested in. And of course, there's some like messy, I don't know, postcode, latitude. Um, yeah, I think that's something we should be able to use. So let's download it. Well, I'm gonna create a new file. Well, I already have K-means tutorial. It's not test, it's real. All right, so yeah. Text file usually has small size, doesn't take a lot of storage, but also it can be opened by Excel, which is super cool. So how do we open that? Sorry, this is something else. And just let's open Excel first and open our file. Because you might have seen another file with name of CSV. They're typically the same type of file, but Excel can recognize recognize a pattern of the data and make it easier for human beings to write. So let's open that. It's real. Yeah, we just downloaded it. Oh, sorry about that. Let's close that and save it and open it again. All right, real whiskeys. Looks like something. But remember, it's sort of messy text file. So Excel is gonna ask you some questions before you proceed. So instead of set the fixed width, because we do not have a fixed width between each word or category, so I'm gonna set the delimited, and you will know what the delimited means. So the delimiters, let's have a look at the data. All of the data are separated by a comma, so we're gonna check that. Look, much better, right? It just directly, automatically divide them into different columns. So next, sounds good, right? That looks like something we're interested in. It looks much neater. Finished. All right, this looks pretty neat. And we have the row ID, we have the name of distilleries, and also the score for each aspect of the flavor. All right, looks great. So let's have a look at what do you need to solve in this business question. So in the question description, you need to divide or do a clustering classification targeting at the different distilleries based on their taste. So in this test, you probably do not need the row ID because they're just like for reference. And do you need postcode, latitude, and something else? I don't know what is that. So yeah, it's a time to ask you, what is the object function here? According to the question, we're gonna do the classification based on taste, right? And taste is our dimension or attributes what we want to have a look at on. So we probably do not care about, where is it located and what is the postcode at. So when we started doing the analysis, we probably do not want to include that because for the first distillery, if the postcode is like 1,000 and the second one is like 0, it doesn't really matter or change the result of the analysis, right? So it's not really relevant to our analysis. But this data set currently looks great. All right, so next steps, let's look at what can we do on BigML. So I really like BigML because it's like really direct and easy to use, but it's not like some platform they can only do regression or correlation analysis. It's like super neat. Not have a BigML account before. It's free for registration, and the maximum file you can make use of is 4 GB, which is definitely sufficient for this assignment. So feel free to register one. And those data sets are existed, and if you have a look at the machine learning tutorial before or recent books, those data sets are pretty classic. Let's say, for example, the Titanic one, you're gonna use that like for the second assignment, but that's also like super structured and patterned, and can do a lot of things on that. So let's generate our own data set. So let's create a source from a local file. You can always generate them through your own data, industry report, or your from the questionnaire. But here, let's make use of our whiskey data. And you might notice that it's a TXT. Does BigML recognize it? I hope so. It's in progress. Actually, one good thing about BigML, it automatically convert TXT file into the data set that it can make use of directly. So you might say that there are already 17 fields with 2 categories, 14 numeric, blah, 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 something. Sounds like exactly like what we had in our data set. So let's have a look at it. So great, exactly. We have the row ID, distillery names, let's say all of the names, body score, and some annoying postcode we do not want it there, but it's in our data set. So that makes sense. But before we throw it into the machine, notice that it's a source, it's not a data set yet. So we want to clean it before we generate our data set. So how can we do that? We configure our source. What you mean is you do some initial pruning in this process. So that's English, separator, blah, 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 looks great. But let's have a look at what do we want to include in our analysis, right? So the question is based on flavor, how many clusters or how are you going to classify all of the distilleries. So do we need row ID? Probably not. Okay, so let's say if a whiskey A and whiskey B, it goes by different row ID 1 and 100, does it really make sense? Because yeah, the row ID here is just a reference, it doesn't really have any actual meaning. So we probably do not need it. The second variable distillery, of course we need it because that's the name of the wine and really the name of the whiskey, and we really want to know what's going on in each cluster, right? But look at the type. It's text, but we probably do not want to regard it as text, as plain text. We want to regard it as let's say our options, a category, because that means like different distilleries at really different categories. So I want to cluster them together. All right. So for the rest of the flavor aspect, it should be numeric because it scores. It's like 2 points, 3 points, 1 point. But well, notice there is something wrong here because tobacco is always also an aspect of the flavor, but it goes by category. So we probably want to fix that. All right. The rest of them looks good. Second page, nutty malty looks good. Postcode, latitude, longitude, we probably do not need that. But for the type, they're like, okay, we don't care. So they're like, okay for now. So let's update it. All right. So I think we're good to go to generate our data set. When you generate it, it will ask you, like, do you want that? Okay, so that's a step. We want to deselect the things we do not care. So let's do a quick recap. Row ID, we do not want that, and the rest of them sounds good. Nutty, multi, fruity, flower. Postcode, no. Latitude, no. Longitude, no. But notice, this is just for this assignment. If you want to conduct a classification based on the location, I'm pretty sure the latitude and longitude here is definitely necessary, which you do not want to throw out. All right. So it's all focused on your object function. All right, sounds good. We have all of the things we want. So the data set, I usually gave it a new name. So let's just say data set. All right, because all of them goes by whiskeys, it's a little bit confusing. All right, let me double check. Yes, we did everything. So create data set. All right, so this is actually like the second step. It's a data frame which really like literally good to go. You're able to throw it into the machine. It's like clear and easy to recognize. And another cool thing about Big ML, it's even you just throw a data frame into it, it can actually generate a general stuff, general sense of the distribution of each score. So we can say like for body sweetness, some of them are like pretty normal distribution, like the middle score. The cases are the middle score. But for medicinal, that makes sense. Like just few whiskey are like medicinal, and also tobacco makes sense. So you can just have a sense of what's going on. Like all of them has 86, so we probably do not have missing value, which is cool. All right, so the data set looks good. And look, there is some sign, like warning sign here, the field is not preferred, which sort of makes sense because they're like, remember it's category, it's like still text. So the machine sort of warns you like, hey, I don't recognize that. What does it mean by names? I don't know what does that mean. So no problem. But remember, we need that because we needed to refer to, okay, I want to know what these itineraries are in my clusters, right? That's like the really important part in the object function. So just keep that in mind. All right, so the next step we want to generate. So the second button here is actually super cool, like all of the model analysis you can do. So model, logistic regression, time series, all of the cool things you can do, PCA. So definitely based on your data set and object function. But currently want to do a cluster. Remember, it's not, this is like a great case for unsupervised learning because you do not have a dependent variable. You do not have a really like a why you want to or you want to have a look at it or you want to predict. It's actually some scattered data points. You want to cluster them together. Okay, so this is definitely a cluster case. But, well, I mean, there are different perspectives you can say this case, but I'm going to do the cluster analysis here. All right, so let's go through the different options here. So first, the number of algorithms, k-means, g-means, we're going to use k-means here. The number of clusters. So this k, as we mentioned in the class, it's really depends of the business case now. So remember, let's go over it, went over it in the lecture, saying like it really depends of the ability of the salesman, the marketing people. Are they able to handle 4 different segments, or do you have the enough money? Do you have enough money or budget to cover 10 different segments? So this K, it really depends on the object function you're going on. So let's say I'm going to work on 5 different markets. My decelerates. I just want to, uh, have a look at different 5 segments. I cannot. I want to have defined event like 100 different segments, but I do not have the ability to do that. Let's assume I can only generate 5 different strategies towards a market. So you change your numbers of clusters into 5. All right, do not model cluster. No, I want to model my cluster, so it's fine. And in the advanced configuration, this is where you need to remember, do you want a decelerate? So remember we want it, but the text itself doesn't make sense to the machine because machine doesn't recognize the name of the whiskeys. So the trick we're gonna do here, we still want it. All right, we want it, but I want to change the scale of it to 0. But I'm gonna keep it. All right. So for the rest of them, we do not change anything because we care about different flavors. It's just distillery. It's a little bit tricky to handle, but we wanted it there. So big ML sort of like automatically deselect the distillery, but we want it. Remember, we still want to keep it into the game. Just to remember to reduce the scale. And this is really important because if you do not do that, big ML or k-means will include this itinerary, even it doesn't make sense at all. It might calculate the distance between the letters or the names, which is a thing we do not want to see. Okay, so all right, we're ready to create our cluster. Take some time, but we only have like 86 Ks. It should be okay. All right, these are our clusters. It's actually really cool. Like you have a visualization of the clusters, but in real case, it's really like abstract. You don't know like where the centroid is, and but this is great. So let's have a look at what does it mean by we have 5 clusters. Well, they are 5 clusters, which is a good thing because we want 5 clusters, so we did that step, right? So the area of the circle or the round shape here is literally the size, refers to the size of the cluster. So let's say this the red one looks pretty big, and it does have 31 instances. And the smaller one has less, and this super small one, has 6. So it makes sense. And we can just focus on this cluster. So click on that and click shift to freeze this cluster. All right, it's locked. So let's have a look at the different category here. So firstly, it has 31 instances. It's a big cluster, and the distillery. This whiskey is definitely in it, but remember it doesn't display everything. So we will talk about it like in 20 seconds or 2 minutes about how do you check what distilleries are in the dataset. But let's look at the scores of this cluster. So the body is okay, which is really just fine. Let's find the extreme values. So what is the highest score of it? Sweetness. So we can sort of, carelessly have generated result that this group of whiskey are comparably, relevantly sweeter. All right, because it's like this is my high score, and what is pretty low? It's my tobacco. So the whiskeys in my cluster are like super not tobacco wise. Anyway, so based on the scores, you can actually have a sense of the features in my cluster, and instead of look at each single one, which takes a lot of time and energy. Let's look at a pretty far away case, like this orange one. It looks really far. It only have 6 instances, and instances is a small group, and this cow lies in it, and it's pretty smoky and medicinal. It's different. It's definitely a different group, and it's not honey. Not really honey, because it's like the score is super low, and it's not flour at all. So it's a attractive whiskey, probably not my type, but as you can have a sense of it, totally different clusters. Okay, let me double check. Because this button is here. Sorry, I did it super fast. But the button there is actually you create a new data set in the name of the cluster. So this data set only have the distilleries in my cluster because look at the count here, it's only 31 examples. So I want to have a closer look at what's going on of this cluster, and I really want to know like what distilleries is in this cluster. If I want to targeting at, I don't know, a really sweet wine. All right. So same as the model button here, you can actually download the CSV, and let's do that. Because currently it's sort of inconvenient because you cannot see what examples are in the cluster directly on BigML, which is okay. We're just going to download it. We name it cluster 3. All right, and let's open it. All right, I don't know why it opens in numbers, but anyway, it works. So in this cluster, it only have the name of the distilleries in this cluster, right? The 31 instead of 86, all of them. So you can have a definite, this is really helpful to your marketing strategy because you want to know what sort of distilleries are in my cluster. So you can have a look at who are in my cluster, who are not. And K means did the cluster like exhaustively. So for this and knock distillery, it's impossible for it to appear in cluster 2. All right, so it might be helpful in your third question. It may ask you like, does the distillery belong to the, I don't know, most smoky group, where you can definitely have a sense of what did I mean by the sweetness group. by comparing the score of the clusters, right? So to make it, let's go back to our clusters. That's this one, right? K equals to 5. Yeah. So for this one, it's really, how do you describe this cluster? I would just say it's sort of really not tobacco, but sort of sweet and floral, right? That's a word and that's a language I'm going to use to describe this cluster. So when you're doing question 3, I will ask you to match distilleries in different groups, which sort of makes sense. All right. Okay, that sounds good. If you have any questions, reach out to us. If you face any problems, feel free to talk. Oh, another thing is, there is another question. Want to ask you sort of the the backstage logic of K-means algorithm. So you might remember that the principle of K-means algorithm is calculating the Euclidean distance between different observations, right? So what do you mean by calculating distance? We learned that in high school or middle school mathematics, you calculate the distance between 2 points. Let's say the first point A has location of x1, y1, seeing the 2-dimension space, and the second point B has location x2, y2, and the distance between those 2 points, or the length of, AB, it's just you take a square root of the x1 minus x2 square. Parentheses, x1 minus x2, then together square, and add one y1, oh my god, it's hard to describe, y1 minus y2, and together square. So 2 parentheses square, add them together, and take a square root. And you want to expand it to 3-dimension, 4-dimension. So you just calculate the difference between different data points in each dimension. Then you take the square of it, then you add them up, then you take a square root of it. Does that make sense? Okay, so to give you an example, let's just do a calculation super fast. So I want to know what's a distance. I'm making a, quote fingers here. I want to know the difference between the distance, the Euclidean distance between Alberfeldy and Alberle. Anyway, I want to calculate that, and how can I do that? It's really easy to do it in Excel, but you're always welcome to do it by hand, draw it, or in R, anyway. But here I'm just gonna do it in Excel because it's really easy. So remember recall how do we calculate the distance between 2 data points. So we use x1 minus x2 because that's the difference, but we want to square it to cancel out the sign of the result, or something like that. Then we calculate each of them. We currently do not need them, so let's just throw it back. All right, so this is the distance, the square distance in each dimension, right? But we want to add them up, so I just sum all of them, and we take a square root. So it's just like SQRT of all of them. All right, so that is the Euclidean distance between Alberfeldy and Alberloh. So generally, if you're asked like between which 2 observations are the most, which pairs of observations are most similar, you can answer that question by calculating the Euclidean distance between them. Between them. All right, so that might be helpful for your last question. And for some pairs of it, you just calculate each of them and do the comparison. All right. I feel like the information is enough for you, and I'm gonna have office hour next week. I hope that will be helpful. Um, just remember to do the readings, and that's it. All right. Have a good night and have a good week, and I'm gonna see you soon. All right. Bye.